Hello everyone, I am Ajinder, Assistant Professor, CTU University, Ludhiana, Punjab. Here today, department school रह गया. Hello everyone, I am Ajinder, Assistant Professor, School. Hello everyone, I am Ajinder, Assistant Professor from Department of Applied Sciences, School of Engineering and Technology. Today we are going to learn about the topic polymer. Let's start. These are the learning objects in which you will learn about the polymers. You will also learn about the different processes, different types of the polymer along with its properties and applications. So before delaying, we are going to start the polymers. So what are the polymers? Polymer is basically large molecules which are formed by the different types of the monomers. If we are going to talk about the definitions, so polymers are derived from the Greek word which is formed by the two different words, poly and mer. Poly means many and mer means units. So here polymers are the large molecules which is made up of the repeating units, that's called the monomers. And keep in mind, all the monomers are joining together by the covalent bonding. Covalent bondings are those bonding which are formed by the sharing of electrons. The next is the polymerization. Polymerization is basically a process through which we can prepare the polymers. In this, we are taking the different kinds of the monomer, and then those monomers are acting together and they can create a polymers. You can see here, this is the ethylene molecule. This is the example of ethylene molecule, and we are taking the n numbers of ethylene molecules. So keep in mind, you will take the n numbers of different monomers. This is the polymerization process, and after a process, all of these molecules are joining together and they are formed the polymers, and that is called the polyethylene. This is example of polymer. Now here you will see here, this is the number of n. Here n is denotes the number of monomers. This n denotes the number of different monomers, but here this n denotes the degree of polymerization. Degree of polymerization. So what is the meaning of that degree of polymerization? See, degree of polymerization is the number of monomeric units in a polymer. Suppose we have a polymer and how many different monomers are joining together, that is calculated by the degree of polymerization. Let us suppose you have a polymer which contains the 500 monomeric units. But how you will know that there is a 500 monomeric units? See here, this is the formula. This is the degree of polymerization. You just have to take the molecular weight of the polymer and divide it by the molecular weight of the one single monomeric units. Now taking an example here, suppose you have a molecular weight of a polymer is 5000. This is the molecular weight of the one polymer, and this is the molecular weight of the monomeric units. Let's suppose it is 50. So just divide 5000 by 50 and the answer is approximately 100. So here we will get to know that here n number of monomeric units are joining together which are responsible for the formation of a polymer whose molecular weight is 5000. So this is the way to calculate the degree of polymerization. So in this way we can calculate the different number of units joining together in a single polymer. Now here you will see the dP, that dP denotes for the degree of polymerization. It ranges from a few units to the several or the 1000 units. Now if the n value is lying from 2 to 9, those polymers are known as the oligomers. If the n value is greater than 10, then these are called the high degree polymers. Now keep in mind, if the value is less than 10, those are called the low degree polymerizations or low degree polymers. If the value is greater than 10, those are called the high degree polymers. So this is the case here. Now I am not writing here n is equals to 1. Why? that the reason is here, because if we are taking just a one monomer, that can't be able to create a polymer. So for the preparation of polymer, the minimum requirement is the number of minimum two monomers, because if we are just a single one monomer, that can't form the polymer. The next one is the most of the polymers is lying from the 5000 to the 2 lakh molecular mass range. This is the mass range of the polymer. What is the significance of this polymerization process? It affects the properties of the polymer. If we are taking the large number of, if the dp value is larger, if it is greater than 1000, greater than 5000, those are called the high degree polymers, and if the value is less than 10, less than 5, those are called the lower degree polymers. The next is the higher degree polymerization, which is typically leads to a stronger and tougher. So more the number of dp value, more is the stronger polymer, and if we are taking the lower number of dp, that's called the smaller one. The next one is the all the micromolecules are the polymer? This is the question now here. And one thing is more here, polymer is those which are joining together, in which the monomers are joining together, and they forms a long chain and a giant structure. So that's called the that is also called the micromolecules, because it has a large units, a large structure. That's called the micromolecules. Now, is all the micromolecules are the polymer? That's the question. So no, all the micromolecules are not the polymers, but all the polymers are the micromolecules. Let's explain it. Now here you will see, this is the structure of chlorophyll. This is the structure of chlorophyll. Is there any repeating unit of the monomer? No, there is no repeating unit. If there is no repeating unit, then this is not a polymer. This is not a polymer. But here, this is the another example. This is the example of polyethylene. So you will see here, this is the polyethylene, and numbers of ethylene molecules are there, and joining together after the polymerization process, it forms the polyethylene. So there are repeating units of ethylene. So in this, we can say that there is a repeating units. So if there is a repeating units, that is a polymer. There is no repeating unit, this is not a polymer. Now, this is a micromolecule. Yes. This is again a micromolecules. Yes. But see here, all the micromolecules are not the polymers, but all the polymers are the micromolecules. So we can say that all the polymers are the micromolecules, but all the micromolecules are not the polymers, because there must be repeating units. The next is the classifications of the polymers. So we can classify the polymers on the 4 bases, means we have 4 types. On the basis we can classify the polymers. The one is the type of the monomers, which type of the monomers we are using here. So that is the one classification, which is further classified into 2 types, that is the homopolymer and copolymer. So this is the one type. The next one is origin, from which we can prepare, we are just getting that polymer. That is the second type of the polymer. So in this, it is further classified into 2 types. One is the natural polymers, which we are just getting from the nature, and the second one is synthetic polymers. This is the second type of the polymers. Now the third one is synthesis. So on the basis of synthesis, we can also classify the polymers into 2 types. One is the addition polymers, and the second one is condensation polymers. And the same way, on the basis of molecular forces, we can classify it into the 4 types. Molecular forces are those forces which are existing between the molecules. That's called the molecular forces. It is also known as the intermolecular forces or intramolecular forces. Generally in the molecules, the 2 types of the forces can be exist. One is the attractive force, second one is the repulsive forces. So collectively, if these attractive and repulsive forces existing between a single molecule, that's called the intramolecular forces. If these forces are existing between the 2 different molecules, that's called the intramolecular forces. So the overall, it's also called the molecular forces. So it is classified into 4 types. What is the elastomers? On the basis of intramolecular forces, polymers are also classified into the fibers. Next is thermoplastics, and the last one is the thermosettings. These are the 4 types on the basis of molecular forces we can classify the polymers. So, let us start discussing one by one of the first one is the type of the monomer. So, on the basis of monomers, as I already said, it is the homopolymer and the copolymer. Homopolymers are those polymers which is made up from the one type of the monomer. Homo, from the name we can also remember that homo means same. So, all those polymers in which just a one type of the monomeric unit is used, that are called the homopolymers. This is the example of the homopolymer. This is the ethylene molecules, and from the ethylene molecules we are preparing the polyethylene, and in this polymer we are just using the only one type of the monomer. So, this is the homopolymer, example of homopolymer. The next one is the condensation. Next one is the copolymers. Copolymers are those polymers in which we are taking the 2 or more than 2 different types of the polymer monomeric units. So, here this is the example of the copolymers. This is the one monomeric unit, buta 1,3-diene. This is the second monomeric unit, which is called the styrene, and all of these after the reaction creates a buna S. This is the example of the copolymers, because we are using the 2 different monomers. At the place of 2 different monomers, we can also use the 3 monomers, 4 type of the monomers, like this. So, keep in mind, if you are using the more than 2 types of the monomeric units and then the reaction is proceed, that's in that way we are just getting the copolymers. But if we are just taking the one type of the monomer and then the polymer is formed, that is called the homopolymer. The next is the origin. Origin is from where we are getting that polymer. So, on the basis of origin, we can classify it into 2 types. The one is the natural polymers, second one is the synthetic polymers. So, what are the natural polymers? Natural polymers are those polymers which are found from the nature. We are just getting from the nature. We are not doing anything else. We are just getting it from the nature. And the second one is the synthetic polymers. Synthetic polymers are those which are prepared in our labs by our scientists, by our engineers. So, all the synthetic one, all the polymers which are formed in the laboratories, those are called the synthetic polymers. If we are talking about the examples of the natural polymers, you can see here the cellulose, proteins, nucleic acids, all of these are the natural polymers. Inside our body, nucleic acids are there, and we know that nucleic acids are formed from the amino acids. So, that is again an example of the polymer. So, inside our body, there is again example of the polymer, and outside we are taking the proteins. Protein is again formed from the monomeric units, which is the amino acids. So, that is again an example of the natural polymers. If we are talking about the synthetic one, that is called the polyethylene, polypropylene, nylon, buna S, all of these are the synthetic polymers which are prepared in our labs. If we are talking about the application portions, the natural polymers are used for the paper industries, in textile industries, in food industries, in medicinal industries. In medicine, we are taking it as our drugs, we are taking the tablets of we are taking tablets of different vitamins or different kinds of the proteins we are intaking. So, that are the examples of the natural polymers. In the synthetic one, the plastics, fibers, films, electronics, all these things comes under the synthetic polymers. If we are talking about the degradation processes, okay, once the polymer is formed, now we want to degrade it, we want to decompose it. So, is there any process? Yes, there are so many processes here. Now, see here, in the natural polymers, these are found in the nature, and that can be degraded by the bacteria which is already present in the nature and by the other organisms. So, the decay of the natural polymer is not difficult. It can be, it is a natural process, it can be decayed naturally. But for the synthetic one, it takes 100 of years to degrade. Like suppose you have a plastic bottle and you are just throwing it outside. After 1,000 years, that plastic will decompose. So, that is a huge time period. Next is the synthesis. On the basis of synthesis, as I already said, it is classified into two types. So let's start from the first one, that is the addition polymers. Addition polymers, from the name it is clear, this is just the addition, plus, everything, just add. So if you are taking the monomer and you are just adding those monomers together, that's called the addition polymerization, or the polymer which is formed, that's called the addition polymer. Keep in mind, I am using the two words. One is the polymerization and the second one is polymer. Polymerization is a process through which we can prepare the polymers, and polymer is the unit which is formed at the end, which is our product. So addition polymers are those polymers which are formed by the addition polymerization process. So what is that process? In this process, we are just taking a one type of the, we are just adding the molecules, adding the monomers. Either it should be a one type of the monomers, either it should be a two different types of the monomers, it can vary. But here we are taking the example of just a single type of the monomer which is used here. That is the example of polyethylene. Now keep in mind, the monomeric unit typically should have the double and triple bonds. Why the double and triple bonds only? Because if there is a double bond, then it is converted into the single one. Let's suppose we have an example of this. This is the your ethylene, one molecule of ethylene. This is your second molecules of ethylene. So what has happened here in this polymerization process? This double bond is converted into the single one. This is further converted, and all of these units join together in this way. So this is the example of addition polymerization. There is no elimination, nothing is removed, just adding, just addition. So that's called the again there is a chain growth polymerization process, means basically it is also the common example of the chain growth polymerization, where the free radical type of the reactions are occurred, and here you will see we are just adding the monomer and we are preparing a long chain. The next is the condensation polymers. Condensation, the word which is something condensed, means generally the water comes in our mind when we are talking about the condensation polymers. So condensation is when there is a elimination of something is eliminated, a small molecule is eliminated, those are called the condensation polymerization process. And the small molecule should be the water, it should be the alcohols, anything, it varies from reaction to reactions. And keep in mind, there should be a functional group. If there is a functional group only, then it is used. If there is a functional group like the carboxylic acid, alcohols, only then it can be prepared. This is the example. This is the adipic acid here. This is the carbonyl. This is the carboxylic acid unit, and here this is the again the carboxylic acid unit. So this is the functional group. So if the functional group is present here, only then we can prepare it. So this is the example of nylon 6,6. We are taking the adipic acid, hexamethylene diamine, and at the end we are getting the nylon 6,6. Here we have sum up all of the addition and condensation polymers. See here, in the addition polymers, the monomer should have a double and triple bonds, while in the condensation polymers, there should be a functional group. In the polymerization reaction, this is the chain growth polymerization and this is the condensation polymerization. A small molecule is eliminated? No. In the addition, there is no small molecule eliminated. Yes, but in the condensation, water or alcohol is eliminated. Applications are, additional polymers are used for the plastics, fibers, films, all these. But condensation polymers are used for the in the textiles, for the preparation of plastics or additives. The next is the molecular forces, that is the what type of the forces are existing between the molecules, that is called the molecular forces. First one is the elastomers, then fibers, thermoplastics and thermosettings. So start from the first, that is elastomers. Elastomers are those polymers that have the properties of elasticity, that is the elasticity property. So from the name, when there is the elasticity, we are just keeping in our mind there is a rubber. Rubber is a very best example for this. Rubber, like we are stretching it, we are stretching the rubber, we are applying the force on the rubber, it is going to stretch, but when we are releasing the rubber, it again reshape, it again just come back to its original shape. So that is an example of elastomers. All those polymers in which the elasticity properties is there, that's called the elastomers. Now see here, elastomers are also called the rubbers. So we have two types of the examples, natural rubber and the synthetic rubber. Natural rubber which we are getting from the sap of the rubber trees, and the synthetic rubbers which we are preparing in our labs, which is the synthetic one. These are the two examples. This is the natural one, this is the example for the natural rubber, and this is the example of the synthetic rubber, the tires all we are getting. Next is the properties. So properties we can determine by this polymer chain. So what kind of a structure of the polymer chain is there, with that we can just get the elastomers, that this type of the elastomers are there. And also there is a polymer chain in the elastomers are typically long and flexible. All are joining together by the weak intermolecular forces. As I already said in the starting, there is a forces which existing between the molecules, attractive or repulsive. There is a very weak intermolecular forces. If there is a forces are weak, that is responsible for the flexibility, but if the forces are stronger, that polymer will not be flexible. So here in this elastomers, it is a weak intermolecular forces, and there is no cross linkage. No cross linkage is there. This is another properties. Cross linkage density is very low. There is no cross linkage between the molecules. Cross linkage are though if this is a one monomer, this is the second monomer, this is the third one, all these are joining together, and there is a cross linkage. Let's suppose this is your A molecule, this is the second monomer, this is the third monomer, this is the fourth monomer, this is the fifth one. All these are joining together by a single one, but there is also a bonding like this. So if there is that's called the cross linkage. So in the elastomer there is no cross linkage. Talking about the applications, it is used for the formation of tires, belts, seals, gaskets, and many other products. It is also used in the biomedical applications like the implants and the drug delivery system. Next is the fibers. Fibers are the long, thin and flexible material which is formed by the spons. Like you have a cotton, this is the example of the fiber, which we are taking the cotton and just rubbing the cotton together. When we are rubbing it together, it is converted back into the fabrics. So that's the example of the fiber. That's cotton is called the fiber. So we have two types of the fibers, natural one and the synthetic one. Same. The natural is those which we are getting from the nature, from the plants, from the animals. So there are the three examples of the natural fibers. One is the cotton which we are getting from the cotton plant. This is the cotton. And the second one is wool which we are getting from the sheep's wool. This is the example of the wool. And this is your example of the silkworms which we are getting from the silkworms. This is the example of silk. Next one is the fibers. Fibers are again next synthetic one fibers. So we already discussed the natural one. Now we are going to discuss about the synthetic fibers. Synthetic fibers are those which are made from the chemicals, from the different types of the chemicals. Yes. So here we are taking the three examples of the synthetic fibers. One is the polyesters, the nylon, and the rayon. This is the example of the polyester which is made up from the ethylene glycol and tetrapathic acid. Then is the nylon which is formed from the hexamethylene diamine and adipic acid. Next is the rayon which is made up from the cellulose. So these are the examples of the synthetic fibers. If we are talking about the properties, so it is determined by the chemical composition, structures and morphology. So with the help of the composition, with the help of the structure, we can identify this is the fiber. The next is the strength, durability. All of these things are responsible for the identification of the different fibers. And the next one is the applications. Application is here, it is used for the clothing, textile, carpets, ropes and the filters. It is also used in the medical industries in the form of dressings, the wound dressings which we are using. Next is the thermoplastics. Thermoplastics are those polymers which are which once were created, then we are melting it. After the melting, it changes its shape, and then we are just preparing it in another shape. Those are called the thermoplastics. First we are preparing the polymer, then we are just melting it. With the increasing the temperature, it is it's when we are melting, it is D-shaped, and now we are just again we are giving it another new shape. That's called the thermoplastics, means which can be melted and which can be reshaped rapidly so many times. And there is again a long chain of molecules which are held together, but the forces are weak intramolecular forces. There is again no cross linkage between the molecules. Like in the elastomers, there is no cross linkage. In the same way, in the thermoplastic there is no cross linkage. These forces can be breaks by the heat, by allowing the polymers to flow. Just providing a small heat, it starts breaking down and then we can reshape it. The example is polyethylene. You can see here you have a plastic bottle, that is the example of polyethylene. Once we melt, once we are just providing the heat to the plastic bottle, its shape is changing, and once its shape is changing, it starts melting, and then after the melting, then we can reshape it. That is the example. This is the polyethylene, this is polystyrene, nylon and polyester. All these are the examples of the thermoplastics. If we are combining up in the stable form, that is the monomer. In the polyethylene, we are using the ethylene monomer. In the polypropylene, the propylene monomer is used. In polystyrene, we are using the styrene monomer. Nylon, we are using the hexamethylene diamine and adipic acid. In polyester, tetrafattic acid and the ethylene glycol. So, these are the monomers which are used. Properties. So, polyethylene is clear and tough, and it is used for the formation of bottles and films. The polypropylene, it is strong and flexible, it is used for the fiber films and the other products. The polystyrene, it is again clear and lightweighted, it is clear and lightweighted, so it is used for the formation of packaging and the forming forms. Nylon, it is strong and durable, it is used for making the fibers and filaments. Next is polyester, it is strong and versatile, so it is again used for formation of fibers and films. The next one is the thermoplastics. Thermoplastics are this is the properties of the thermoplastics. So, in this, again with the help of molecular weight, we can identify the thermoplastics. With the help of degree of crystallization, we can again identify the thermoplastics. So, what is the crystallinity? That we are writing here the word degree of crystallinity. Crystallinity is the degree to which the polymer chains are arranged in a regular order, means in which order it is arranged, either it is a isotactic order or is it a atactic order, or last one is a syndotactic. So, these are three types of the orders. Next is the thermoplastics. Thermoplastics are recyclable, we can recycle it again and again in so many types. And the next is applications. It is used in packaging, textile, automotive and electronic industries. The last one is the thermosettings. Thermosettings are those polymers which once we prepared, and then we are trying to melt it, it will not melt, we can't reshape it. So, that is called a thermosetting, means once it is prepared, it is set. From the name it is clear, it sets and then we can't change it. So, there is a cross linkage, yes, there is a cross linkage, there is a long chain molecules with the cross linkage. These are the examples: bakelite, melamine, epoxy, all these are the examples of the thermosettings. It is used for making the kitchenwares. You can see here, these are the few monomers of the bakelite. In this, polymer and formaldehyde, phenol and formaldehyde is used, melamine and formaldehyde is used, epoxy, bisphenol and this epochlorohydrin is used. These are the properties of the different polymers, and it is used for making the electronic compartments, kitchenwares, combs, fountain pans, tablewares and additives coatings. So, all these things are about the thermosettings. If we are talking about the properties, it is again identified by the cross linkage, by the molecular weight. And keep in mind, thermosettings polymers are not recyclable, we can't recycle it again and again. And the applications are, it is used for the electrical, automobile and the construction industries. So, these are the few industrial applications of the polymers. It is used, this plastic is the one which is used, and the next is additives, and next is the coating. So, it is used in the plastic industries. With the help of this, we can make the additives. With the help of polymers, we can prepare the coatings like different paints, varnish and liquors. The next is fibers. We can prepare the different fibers. It is used in the textile industries, elastomers. In the automobile industries, we can also use the polymers. So, it is used for making the rubbers, nitrile rubber, etc. It is in day-to-day life, what are the applications of polymers? It is used for using the food packaging, like in the textile industries, for making the cloths, carpets and towels. In the electronic industries, circuit boards, wires, insulations. In the construction industries, pipes, roofing and sidings. All these are the applications of the polymers. The last one is the medical devices. For the preparation of medical devices, it is used in so many ways. So if we are concluding all of these, polymer has a very wide application. It is used in so many fields. If we are talking about the textile, automobile industry, medical industries, construction, food packaging, there are so many wide applications. So thank you.